So do you want the razzle dazzle of the methodology, the 10-minute
I
version?
mean, I'd love to, and then I'd love to hear more about what you're up to, Leanne, as well. So I don't know how much time we might need more calls. I can sit for a while, but I don't know what you guys
I would highly recommend getting the razzle dazzle from Susan. Espen, you and I can totally catch up another time as well.
All right.
It's phenomenal. Right.
Let's do the razzle dazzle. I like what I hear. So.
All right. I just have to find. Geez, how many desktops do I have open? Let me see. Share over here. Share that one. Good. I think this is us. All right. This is a little razzle dazzle aimed at Orkney, because that's where we're going. We've got a mission, this Island Center for Net Zero, that I'll be the academic lead on. We're working throughout the 3 Scottish islands on the mission given by the Scottish government to get to net zero by 2030. So there's your constraint. Just do that. And so the idea there is that the people of the islands are different in that they just deal with stuff, get on with it, solve their own problems. And so they can make headway in headlighting for the rest of the UK, what direction, what we do, what might we do, what innovations come out of this. So our sort of process is where have we been? How did we get here? And what do we do next? That is a very Indigenous perspective on how you pathfind forward. And we are working on tourism, housing, everywhere where carbon is. The ferries are a huge thing, transport and land transport. So that's our basic mission there. Now, when you apply that nice thing of net zero by 2030, then you have to start focusing on what's actually essential or important in what you're doing. And that is a challenge for most people. So that's where we start, is to sit down and say, okay, well, what's actually essential? And talk about a specific place, a specific organization, and what's essential about what they're doing. If you find that there's things that aren't essential, that are optional, then you can park those to the side for discussion later. But what we need to do is make sure that we preserve our essential and important activities. Now we look at how we are doing them now, and we see that the way we're meeting those essential needs is fossil fueled. Why? Because it works great. No better answer than that. However, we do know it's not sustainable, but it's what we're using to meet our needs. And therefore we are going to be quite nervous if you talk to us about changing that. And we'll do things like jump to, well, but I can't do without it. Well, that's not what we were actually talking about. We were talking about change, planned change, not a shortage. So a planned change. And we also have people who very often will get quite hung up on the harms caused by the things that we're doing, which is legitimate. Because there's a lot of harms. And so we can agree that things must change, and that we want them to change in ways that are logical and that aren't harmful and that produce more benefits. We'd actually like to go to a better place while we're at it, but we can also agree that the probability of change is quite low because we just really can't change because what we're doing works. So what we're going to do once we've identified this essential activity and we've sat down with stakeholder cohort to work through that little spinning wheel of death there, which is what we're going to, just for a moment, imagine that next year we know for sure there's going to be a 10% fossil fuel reduction in the supply. Can you think of what you would do? And so we'll have some discussion about that. And there can be some good ideas that come out of that. And what you see is that that's fat cutting at that level, because 10% isn't very much. So that'll be carefulness. That'll be cutting out things that are wasteful. Okay, well, now I'm going to tell you that the next year there's another 10% coming. So now we're up to 20% downshift in 2 years. Can you think of what you do about that? And now we're starting to get out of the territory of what people can imagine. And I'm going to say, okay, and net zero is an 80% downshift in fossil fuel in the next 8 years. And so are you ready for that? And that's where the answer is almost universally no, because what we've got here is a wicked problem. A wicked problem is where we don't know what we don't know. We haven't been here before, and we don't actually have that plan. we don't know what cost that would be. Just no, mind blown. And so that means that we're ready for transition engineering. So this is the problem of our era. This is where we are, and the systems which must change continue to satisfy needs, continue to support the essential activities and services are engineered systems. And so we're going to rely on the engineers to come along with us on this. And this is transition engineering. If you can get the little book, I promise it's readable. It is interdisciplinary and not just multiple disciplines of engineering. It's interdisciplinary in all peer disciplines and stakeholders and end users. So a whole system, design thinking, if you want, or systems thinking, yes, all of that. But it's about transition this time. We've been doing the projects of growth and projects of new stuff, and now we're going to do the projects of transition. And that's going to require innovation in a way that we might not have seen innovation before. It's going to require management, which means things have to be done out of profit and within the margins of what you can actually do in a given year, and it's all going to require engineering. So this is our methodology. Because we're stuck with a wicked problem and we actually don't know even probably what the reliable information is, the data that we need, we probably don't even have. We certainly don't know what policies would be involved there. We don't know what we're going to do next. So we park that for a moment and we don't work on it anymore. What we're going to do is that essential need that we had worked on and agreed, this is our essential need for stromness in our schools, so something specific. We're now going to get together as a cohort, and we're going to get in our time machine and go back to 1911 in that place, and we're going to inquire and explore about how that place in 1911 was meeting that essential need. Were they doing a good job of it? Did they have the same wicked problem we do? How were they actually doing it? And we're just going to explore. No, we're not saying we're going to go back in time at all as our solution. We're going back in time to learn how other people who are very much like us, they're our grandparents, how they do stuff. And then we're going to have a very good time doing that. And what it's going to do is it's going to release the pressure that we feel when we are thinking about change. And it's going to build the relationships and the communication skills of the people, of the stakeholders who are working on this, because we can all learn history. This is what Ken Burns knows, that we are all interested in history. This is what Antiques Roadshow knows. And we're interested in, especially in understanding the values of our people at different times. So we get this cohesive process from really exploring the history of this question, and then moving through time now, coming towards our time now, and understanding the dynamics of change of that system. Remember, we were having a very hard time understanding change, but the last 100 years have been nothing but change. So we're going to actually study that change. The other thing we're going to try to pick out is the relevance of technology, market, cost, social, these different aspects, environmental aspects, the accessibility of resources, the types of resources accessible, education, all of these things. How, as we go along through time, do they change, and how do they affect each other? And that can be quite anecdotal. It doesn't have to be scientific, but if it's informed, that would be good. So if somebody can do some research ahead of this work and actually have those answers for the cohort, that's good. Then we need work done on getting the present data. And that's where there's projects there, just in, like you say, digitizing the data that we don't have at the moment and getting it so it's accessible. We also have projects in our program in data curation. We have to find new ways to actually collect data and use it, because we don't have what we need right now. Leanne has to go. Her things are dropping out. All right. So we have figuring out what's present, and then we need to explore what, if you fill in the blank, we could, right? So we could keep going, and that will run into a crash at some point. We could have behavior change of people, okay? And will that get us to where we want to go? We could have technology change. We could have policy change. So the things that we think we could do, we need to crash test those and see if this future here exists. Because if it does, if that's correct, then we need to just get going on that route. If those things that we think we could do aren't actually a possible future, then we need to put those aside and stop thinking about them. Thinking about the things we could do is a way to really not get going on our direction change. And that's what we're pretty sure we need in order to do this downshift of fossil fuels and get to net zero. So once we do that, which requires engineering input to actually do the analysis and communicate to people who maybe have invested a lot of belief in hydrogen, for example, that no, really, we have to park that off to the side for now, because it doesn't meet, it's not going to help us with this 80% downshift by 2030. It's not going to happen. All right, so now we launch off in our time machine again, but we're going to the future. And we're going to 2121 that we choose. We have to be very careful which 2121 we pick. We're going to our same place where we're working on meeting this essential need. By 2121, the ships we're using, the trucks we're using, they're gone. They've been through the scrap heap and probably recycled a couple times. The solar panels.
Susan, do you mean 2131 or 21 like this year?
2121, 100 years from now.
Oh, sorry, 21. Yeah, sorry, I was still in 20. Yeah, so we're 100 years ahead. Okay,
we're going way out there. 100 years from now.
Got it.
We actually did a lot of research about if we're going to try and understand the future, how would we do it? Because as a species, we haven't actually figured that one out. I actually think we have figured it out, and it's tradition, that's how we look at the future, because tradition means we're going to create it by doing what we know works. And so that's why we're so ill-equipped for a future that is demonstrably different from our present, and from where we think we're going to continue to go. So what we do is we land in, let's say, Stromness in Orkney in 2121. And what we do know from experience is that a street that's here now is probably there then. That's how streets go. A lot of buildings, there's some buildings we can look at them and go, no, they're not there anymore. But there's the university building is still there. The church is still there. That church built in the 1400s, they've kept that up and it's still there. The port is still there. There's a lot of things that are actually very similar to what they are today. And then there's something for sure, which isn't there, and that's oil for consumptive purposes. There's oil for production of essential goods, but that's about it. And so that's interesting, because where all this carbon that's cooking the planet is coming from is the stuff that's not there anymore in the future, 100 years from now. And so we can start to look around and start to interrogate how those people are doing what they need to do without that amazing crutch of oil and gas and coal to entertain themselves, to have convenience and that sort of thing. So that is a big piece of work there that requires engineering input, because we can't actually invent any technologies that we are magical. That's not a thing. We have to actually figure out what would work in that context. And that, I think, is quite a different future visioning exercise than most of the visioning that people do, where they sort of go off in these directions that probably don't really exist, that very low probability of existence. So this one, we're going to choose the future we get to, where the 1.5 degree centigrade overheating actually has been averted, which means that right back here, everybody who needed to do something right did it. And that's what we're going to actually try and trigger. So after we have this nice exploration of the future, we then backcast, and what we're asking here is what they are able to do in the future that we are not able to do. And that has really interesting answers. You know, one of the biggest answers that we've found when we visit the future is they are able to wait. That's a skill. We are not able to wait because we got fossil fuels. They don't have fossil fuels. They are able to wait. So what kind of enabling technology or information systems could we invent now that would allow us to wait so we can become more like them? Good question. For example, now when we backcast,
that's a tall order.
I know it's not a thing that we've thought about because we've written it off as what we shall not do, right? We always want faster. We want less waiting. We want instant. Well, what we see in 2121 is that they have the resource of waiting as one of the ways that they meet their essential needs without oil and gas.
Are you familiar with the work of the Long Now Foundation and that line of thinking?
You said the what foundation?
The Long Now Foundation. There's a book called the Clock of the Long Now. It's I think they started off in the Bay Area. Their purpose originally was to build a clock that would last for, I think it was like at least 1,000 years. So they built this mechanical clock using some brilliant engineering that's literally supposed to last for 1,000 years. And there's a book written around it as well, which is, it's got to do with our sense of time and how we perceive time in terms of exactly what you're talking about, like the willingness to wait. Right. And I think you'd find it relevant to what you're talking about as well.
Well, essentially, at this point, I'll step away from a methodology for a minute and just say, I am pretty sure that this pressure for change, the pressure of knowing that we are running full blast towards a bad place, has triggered concern and consideration amongst a huge number of people. And that is being expressed in a lot of different ways. And that we are right now at a point where the convergence of all of that intention is the key to getting to that future we want to get to. These convergences have happened throughout history. One of the famous ones in mechanical engineering is Rankine, right? Actually being able to sit down and on paper explain the steam cycle and how the methodology for doing steam engine design and analysis. That was a massive breakthrough when people had been making steam engines for 150 years. But it was after that that you could make lots of steam engines really quickly, and you could standardize parts and you could learn from each other, and like that. That's when it gets unleashed. So we need to unleash the impact of all of this intention by standardizing the method, basically. And so this 7-step method that we've got here, that is an amalgam of just about everything we could find that's going on, and in fact, it's not just an amalgam, it's a solution to the problem of the 7 blind men and the elephant, because of the impassionment of the people who are looking for solutions, they become quite blinkered about that they've got the solution. And then they just keep going off in their own direction. But to really achieve this massive transformational change and massification of that change, we have to all find a discipline that we can all be following. And the long-term design, this is sitting right in here, these shift projects. You've already nutted out that you need to be able to design something that lasts 1,000 years, and you take on that challenge to do it and learn from it and get bigger, learn much bigger lessons from doing that exercise. And that is exactly what we're looking for. Now, Are we done because one group did it? No, absolutely not. We have to, like, everybody has to do that now for whatever it is they're looking at. So the shift project is where we're trying to get to, because it doesn't do any good to philosophize or to explore and have a good time. You have to actually do a project that embodies a change in this new direction of carbon downshift. You have to learn from it. That's the blue feedback cycle there of learning. And you have to look forward to, when this project is successful, what are the unintended consequences that we have to work out before we invest in the scale up? What are the policies that we need to unlock it? What are the synergies with other things? So we have to do a sort of whole system transition analysis from our project. And that's our 7 steps. And then that learning sometimes will take us back through the whole process again, or it'll just, we'll be on the right path, and therefore we'll just keep going then as we do. So this 7-step process, in my book, I give people the story, if they haven't heard it, of the 7 blind men and the elephant. And these, well, at least 1, 2, 3, 4, and 5, and to some degree 6, are positions or perspectives that if I got a room with 50 people in it, they would break up pretty evenly into people who look at the past a lot. And they don't communicate very well with people who are looking at, well, we could do this, we could do this, and they don't, you know. Then there's the politicians and the economists who really look at very short-term questions and answers. Then you got the big dreamers who, you know, go off into the future, and a lot of them are sort of just zooming around out here somewhere. They're not actually anchored in a real useful examination of the future. And then you've got the engineers going, okay, but what do you want me to build? Okay, but what are we going to do? Okay, but what are we going to do? And nobody knows. So we don't actually get anywhere. And when we all sit down and we say, okay, they have something to teach us, so let's all learn from this, and then let's all learn from this and get the data we need, and then let's all talk about this and decide if we really want to spend any more time on it right now, and let's all talk about this, and then we can actually move through this whole process and get on with work and find projects to do. So our projects in Scotland are wherever carbon is, that's what we're working on, forming cohorts, going through this process, we get to project ideas quite quickly, actually. And then we need to get on with them. And that's where all the engineering supports, the gamification, the digital twins, the digitization, that's why we have a huge amount of support for all that kind of work, because it just keeps popping in wherever you look. Yeah, so that's our...
Where do you feel like the biggest challenges are right now, Susan, in terms of the sort of implementation using your process?
I would say my inability to get that little simple idea out, because underneath this is the simple idea that we are going to actually look for something different. And I'll call that the flip side, the counterfactual. You know, what we're doing, we have to recognize we've been doing that for too long now. We keep talking about, oh, we'll go to solar panels. Well, a little bit of calculation shows you that, no, actually, that's not what we're going to do. Yes, we're going to have solar panels, but we're not going to substitute coal for solar. That's not a thing. Or, you know, I don't know. There's all this noise that goes on. And so just saying, okay, well, counterfactual, we're going to use less oil. We're going to use less gas. Now you ready to talk?
And is that so? Because I've heard you use quite a few different examples, but primarily around energy reduction. So transition engineering as a process, it sounds like it could actually be applied to quite a few different types of challenges.
Oh yes,
right.
We've done waste, we've done
exactly.
product design, we've done,
Well, that's very impressive. I like the process, and I have a bit. I'm not an engineer. I have a process background, so there's a lot of the arrows and workshop style challenges are quite familiar to me.